Alright, so in the last video you saw that graphing quadratic functions is actually very easy if the quadratic function's in standard form. And so what I want to do in this video is show you how to put something that's in the form ax squared plus bx plus c to put it into the form f of x equals ax minus h quantity squared plus k. So how do we find h and k? Well, h is always actually going to be negative b over 2a. And you can derive that using completing the square. And then the k value is actually going to be f of negative b over 2a. Because if you think about this, if I know that this is a times x plus b over 2a squared, right? So h is negative b over 2a, so you get x minus h is x plus b over 2a squared. And you want to figure out what this k value is. You just plug in negative b over 2a in for x, and this whole first part vanishes. Right? So that will be 0 when x equals negative b over 2a. Right? So you plug that in, and then this evaluates to 0. That's what I'm saying. So that gives us just k. We're just left with f of x is equal to k. All right. So let me say this again. The vertex h comma k is always negative b over 2a and f of negative b over 2a. Okay. So that will give us the vertex, and then we'll find the y-intercepts and the x-intercepts once we have the standard form. Okay. So let's do this for an actual example. First, we'll find the vertex and the intercepts for f of x equals x squared plus 4x minus 1. All right. So step number 1 is to find a. And you can do that just by looking at the equation. I know that a is 1 here, so a equals 1, which is greater than 0. So I know already that this graph is going to be a u that's facing up. It's smiling. Right? Okay. Step 2 is going to be to determine the vertex. So find the vertex, which I've been calling h comma k. And again, the key here is to first find the x value, or the h value. And I know that h is going to be negative b over 2a. So, let me just write down. A is 1, b is 4, and c is negative 1. Okay. So to find the vertex, we just take negative b, so negative 4 over 2 times a, which is 1. So already I know that h is going to be negative 2. And then to find the k value, to find that y value of the vertex, you just take f of negative 2. So that's negative 2 squared plus 4 times negative 2 minus 1. Well, what does that give us? That gives us 4 minus 8 minus 1. That's negative 5. Okay? So what I just found is that h comma k should be equal to negative 2, negative 5. And so my standard form of this equation then is 1 times x minus negative 2 is plus 2 squared minus 5. Okay, so you could check that if you multiply this all out, you would also get x squared plus 4x minus 1. Okay, so these are two different forms of the same equation. Okay, now that we have it in standard form, we can find the x-intercepts using the square root property. So to find x-intercepts, all we're doing is setting y equals 0. So let's set f of x equal to 0. So we have 0 equals x plus 2 squared minus 5. So I add 5 to both sides, and I get x plus 2 quantity squared, and now I'm going to take the square root of both sides, so I better have a plus or minus. there, so that gives us plus or minus 5 equals x plus 2. So x is equal to, plus or minus square root of 5 equals x plus 2. So x is equal to negative 2 plus or minus the square root of 5. And so those values, I'd actually have to plug into a calculator to see where they're at. But one is about 0.024, and the other one is negative 4.24. So approximately negative 4.24. Okay, so let's see here. This is going to be the 0.24 is the negative 2 plus the square root of 5, comma 0. That's kind of approximately 0.024, 0. And the other one's over here, 4.24, negative 4.24. So this will be negative 2 minus square root of 5, 0. And remember my vertex, h, k, was negative 2, negative 5. So it'd be over here, down to, or back 2, down 1, 2, 3, 4, 5. That's my vertex. My y-intercept, to find that, we plug in 0 for x. So now you have f of 0 equals 1 times 0 plus 2 quantity squared minus 5. So that's 4 minus 5, or negative 1. So 0, negative 1 is my y-intercept. And then the final step is just to connect the dots. Kind of a nice U-shaped pattern. Okay, so that's just kind of an application of some of the theory we learned last time about how to solve quadratic functions.